Question 12 students. Find the ratio in which the y-axis divides the line segment joining the points 5 minus 6 and minus 1 minus 4. Also find the point of intersection. So here students, in this case we have to consider the ratio which the y-axis divide the line segment. Okay, so here we consider here saying that let the point O, point O 0y divides line segment. Consider the line segment AB in k:1 ratio. Divides line segment AB into k:1 ratio. So now here there are the 2 points A and B. A 5 minus 6, consider x1 y1, and here x1 is equal to 5, y1 is equal to minus 6. Now here the B, that is a minus 1 minus 4. So consider as x2 y2, and then x2 is equal to minus 1 and y2 is equal to minus 4 students. So here, and also that m is to n, the ratio is k:1. So now here by using the section formula, yes. So by using section formula, that section formula here that consider the point P, here O0y, O0y which is equal to nx2 plus nx1 upon n plus n, and here my2 plus ny1 upon 2. Okay students, and then here m that means the k multiply minus 1 plus 1 multiply 5 upon here k plus 1, and here k multiply minus 4 plus 1 multiply minus 6 upon k plus 1. So now here minus k plus 5 upon k plus 1, and here minus 4k minus 6 upon k plus 1. Okay, O0y. So now equating these both the sides. So here minus k plus 5 upon k plus 1 is equal to 0, and minus 4k minus 6 upon k plus 1 is equal to y. So now here minus k plus 5 is equal to 0. That means minus k is equal to minus 5, and that means k is equal to 5. Okay students, here k is equal to 5. Now here put this value in this equation, that is k 5 minus 6 upon here 5 plus 1 is equal to y. Then here minus 20 minus 6 upon 6 is equal to y. So here minus 26 is equal to 6y. So here minus 26 upon 6 is equal to, here do not state this, minus 26 upon 6 is equal to y. So here minus 13 upon 3. So y is equal to minus 13 upon 3. Okay, so the point the point O having the coordinate 0 minus 13 upon 3. 0 minus 13 upon 3. And here the point of intersection the point of intersection is 0 minus 13 upon 3, and the ratio that is the k is to 1, which is equal to, the k means the 5, so 5 is to 1. Ratio is 5 is to 1. So this is our final answer. Question 13, students. If the points A 6 1, B P2, C 9 4 and D 7 Q are the vertices of the parallelogram ABCD, then find the values of P and Q. Hence, check whether ABCD is a rectangle or not. Here the given is that the ABCD, quadrilateral ABCD, is a parallelogram. So here, students, that if you draw the parallelogram here, then A, B, C, D. Okay. Then here opposite sides are congruent, and but here if you draw the diagonal, AC and BD, then we can say that here the midpoint, of AC and the midpoint of BD are equal. Okay, midpoint of BC and the midpoint of AC are equal. Okay, so that means here I write down that the midpoint of AC, here first write down quadrilateral ABCD is a parallelogram. Okay, therefore midpoint of AC is equal to midpoint of BD. Okay, so now here first I calculate, that is A, and A means the 6 1 coordinate of A are 6 1, and consider x1 y1, and x1 is equal to 6, y1 is equal to 1. Then here C, the coordinate of C is 9 4, so consider as x2 y2. So here I write x2 is equal to 9 and y2 is equal to 4. Okay, students, and then here the BD, also for the coordinate of B, that is a P2, consider as x1 y1, and x1 is equal to P and y1 becomes 2. So then now D, the coordinate of D are 7 Q. So consider as x2 y2, then here x2 becomes 7 and y2 becomes Q. Okay, so now here midpoint of AC and midpoint of BD. So the formula of this, that is x1 plus x2 upon 2 and y1 plus y2 upon 2. Okay, the coordinates, we get the coordinate. So now here also the same formula, x1 plus x2 upon 2 and y1 plus y2 upon 2. Okay, so now here x1 plus x2, that means the 6 plus 9 upon 2, and here y1 plus y2, 1 plus 4 upon 2. So 15 upon 2 and here 5 upon 2. Okay, and here which is equal to x1 plus x2, here p plus 7 upon 2 and here 2 plus q upon 2. Okay, here p plus 7 upon 2 and here 2 plus q upon 2. So now here students, equating both the sides. So p plus 7 is equal to upon 2 is equal to 15 upon 2. Okay, so that means p plus 7 is equal to 15, and that p is equal to 15 minus 7, p is equal to 8. Okay, and here and 2 plus q upon 2 is equal to 5 upon 2. So 2 plus q is equal to 5. That means q is equal to 5 minus 2. So q is equal to 3. Okay, the value of p is 8 and q is 3. Okay, so that means we solve the first question. Then the next one, that is check whether ABCD is a rectangle or not. So for ABCD is a rectangle or not, then that means we have to check that is a diagonal, the length of the diagonal is equal to the length of the diagonal BD. Okay, so that means length AC is equal to length BD. That we have to check out. So here by using the distance formula, so here x2 minus x1 and y2 minus y1. So here x2 minus x1. So see here x2 minus x1. Huh? This is AC. So x2 minus x1, that means 9 minus 6 whole bracket square plus y2 minus y1, that means 4 minus 1 whole bracket square. So here 3 square plus 3 square. So here 9 plus 9, so which is equal to root 18. That means the 3 nines are na? 3, 2. So 3 root 2. Okay, so here 3 root 2. And here AC, BD, for the BD also use same formula x2 minus x1. So BD, that means x2 minus x1, 7 minus 8. 7 minus 8 whole bracket square plus now y2, that is a q means 3, 3 minus 2. 3 minus 2 whole bracket square. So here the square root minus 1 whole bracket square plus 1 square. So that means 1 plus 1 and that is equal to 2. So here AC is equal to 3 root 2 and BD is equal to root 2. So now AC is equal to 3 root 2 and BC is equal to root 2. That means both the answers are different. So as AC is not equal to BD, therefore we can say that quadrilateral ABCD is not a rectangle. Is not a rectangle. Okay, such a way we can solve this example.